Good morning, students. I'm your Nagini ma'am. Today I'm going to discuss about how to calculate formula of the compound. Okay, students? Right. Now I'm taking cubic unit cell. See, students. So in cubic unit cell, these are the corners. Yes. So total how many corner particles? 8 corners, correct? So these are all corners. Okay, and next this one is arrow. This is called edge center particle, and this one is edge. Okay, and next face centers, I'm taking here one face center. This is face center particle, and next this one is body center particles. Correct, students? See here, once these are all corners, total 8 corners will be there, and this is the edge center, and this is edge. These are all edges only. From corner to corner, this distance is called edge. So this is edge center, this is edge, this is the face center, this is body center. Clear, students? Body center. Here how many corners will be there, students? Total how many body center particles will be there? First of all, body center particles 1, correct? Only one body center particle will be there. And next, how many corners will be there, students? In cubic unit cell, total 8 corners kada. 1 2 3 4 5 6 7 8, total 8 corners. And how many edges will be there? 1 2 3 4 5 6 7 8 9 10 11 12, correct? Total 12 edges will be there, students. Okay, edges 12 edges. So edge centers also same kada, 12 edge centers will be there. How many faces? Edge centers also 12. How many faces, students? Total faces 6. Face centers also how many? 6. Clear this one? Face center 6. So one body center particle will be there. And next, corners 8 corners, so edges 12 edges, so edge centers 12, faces 6, face centers 6 will be there. Clear, students? This is about the cubic unit cell. Okay, now see, students, how to find the formula of the compound. So how to find out formula of the compound? So I will take one question, students. A cubic unit cell is made up of 3 elements X, Y and Z. Okay, Z. Now X atoms are present at the corners. X atoms were their, students? Corners. And Y atoms are present at the body center. Okay, at the body center or cube center. And Z atoms are present at the face centers. Clear? Face centers. Now we have to find the formula of the compound. Clear? So before going to calculate the formula of the compound, first what are the contributions you should know the contributions of body center particle, corner particle. So what is the contribution of body center particle? What is the contribution of corner particle? So first I am going to discuss that one, contributions. Later we can discuss this problem. Understood, students? So first of all, I am taking the total 8 rooms, students. In the ground floor 4 rooms. See here, I am taking total 4 rooms. Suppose like this. So this is the ground floor, students. This is ground floor. This is first room. This is second room. This is third room. This is fourth room. Okay na, this is the ground floor. As it is first floor I am taking above this one, exactly above this one first floor will be there. Just you imagine students. Okay now, here in the ground floor 4 rooms are there, first room, second room, third, fourth. As it is above this one again 4 rooms are there, total 8 rooms in the ground floor and first floor, total 8 rooms are there. So first I am considering the first room. Okay nama, so only first room I am taking. Okay, first room. So this is, suppose this is the corner particle, correct? So this is the corner particle. So now this corner particle, it is sharing with how many rooms, students? This, that how many rooms this corner particle, it is sharing with this room, and this room, correct? These 4 rooms are touching, correct, this point. So this corner particle and this 4 rooms and up 4 rooms also touching this particle, correct or not? So that's why total 8 rooms are total 8 rooms are touching this particle, correct or not? That means this corner particle is sharing with 8 rooms. Are you following, students? So this corner particle is sharing with 8 rooms kada, that means 8 unit cells anamata. Okay na, 8 unit cells. That means each corner contribution is how much, students? 1/8. Clear this one? So I am taking the corner. How many corners will be there, students? 8 kada. Here I told you 8 corners. So each corner contribution is how much, students? Each corner contribution is 1/8. That means one corner particle is sharing with 8 rooms. Okay na. Now I am taking the edges. Okay na. Now see, students, edge center I am taking. Okay, now this is the edge center. Suppose I am taking this edge center particle. Now this edge center particle is sharing with how many rooms, students? First room, second room, and up which room? So this above this one, first and second room, up 2 rooms will be there na. So that 2 rooms, so this 2 rooms. So total, so upper rooms are ground floor 1, 2, 3, 4. First floor is 5, 6, 7, 8 anamata. Okay, now I am taking this one here only, 5th room, 6th room, 7th, 8th. Okay, now see, students, I am taking the edge center particle. Now this edge center particle, it is sharing with how many rooms, students? First room, second room, 5th room, 6th room. This 5th, 6th room, where there, students? Above the first and second rooms, correct? So it is sharing with 4 rooms kada. That means each edge center particle is sharing with how many rooms? 4 rooms. So that's why each edge center contribution is how much? 1/4. Clear this one? Edge center contribution is 1/4. Okay, now I am taking the face center. Suppose I am taking this face, students, this face center, this center particle I am taking. Okay na, this face center particle. Now it is sharing with how many rooms, students? Face center, suppose this is, I am considering as a face. This face center particle is sharing with how many rooms? First room and 5th room, correct or not? Remaining rooms are not touching, correct or not? This face center particle is sharing with the first room and 5th room. That means it is sharing with only 2 rooms. Is it correct? Understanding, students? So face center particle is sharing with first room and 5th room. Are you clear this one? So that means it is sharing with 2 rooms. So that's why face center contribution is how much, students? 1/2. Now I am taking the body center. Suppose this, in this room, middle there is a one particle. Okay na, body center particle. So that means it is not sharing with any other particles. Are you following, students? Suppose one room you take, in the middle of the room take one particle. Okay na, body center particle. That particle is sharing with any other unit cells? No. Any other rooms? No. That means that body center particle does not share with other rooms, other unit cells. Are you clear? Other unit cells. That means that body center particle, it is sharing with that particular unit cell only. Okay, so that's a body center contribution is how much, students? 1 only. Clear this one? So body center particle share contribution is 1. That means only one particle it is sharing with that particular unit cell. And that edge center particle, this is the corner particle. Clear this one? So I discussed your body center particle, edge center particle, and face center particle, correct? So these 3 I discussed. Clear this one, body center and corners. Okay now body center particle understood, amma? So in this room middle the particle is there, it is sharing with that particular unit cell only, so that's why its contribution is 1. That means it is sharing with that room only. And corners, if you take this corner particle, it is sharing with how many rooms? That means it is in touch with the first room, second room, third, fourth, up to fifth, sixth, seventh, eighth, all 8 rooms are touching. That's why its contribution is 1 by 8 students. Now I am taking this is edge center. I am taking edge center particle is sharing with how many rooms? Edge center means here first room, second room, up to fifth, sixth room. That means total 4 rooms sharing. Are you following? So total 4 rooms are there. So that's why it is equal to 1 by 4 contribution. Face center contribution is 1 by 2. Okay. Remember this all students, then we can easily calculate. Now what is the question students? A cubic unit cell is made up of 3 elements x, y and z. X what students? X atoms are present at the corners, Y atoms are present at the body centers, and Z atoms are present at the face center students. Now what is the formula of the compound is asking question. So what is the formula? So formula you have to find, formula of the compound. How to find students here? How to find it? So number of atoms of X per unit cell. Suppose I am calculating X value. Okay, X value. Where there X corners? How many corner particles will be there students? 8 corner particles are there, and each corner particle contribution is how much students? 1 by 8 kada. This is contribution students. Okay, so 1 by this is corner contribution is how much students? 1 by 8, correct? So 8 will get cancelled. How much? 1 remaining. Now see students, Y atoms where their body center, correct? Y atoms are present at the body center. Okay, so that means how many body center particles are there? Only 1, and its contribution is 1, correct? 1 particle, 1 contribution, so it is equal to 1. And Z atoms are present at the face centers kada. Face centers means how many face centers will be there students? Total face centers 6 kada. 6 into what is the contribution of each face center? 1 by 2. Clear this one. So then you will get 3. So what is the formula of the compound students? Therefore formula is equal to formula of the compound. Formula of the compound is equal to x1 y1 z3, correct? X y z3. Clear this one. So xyz3, this is the formula of the compound. Now see students, one more question I am discussing. One more. Now see students, so next question, if 2 atoms of X are missing, okay na, if 2 atoms of X are missing from the corners and 2 atoms of Z from the face centers, okay na. So here from Z 2 atoms, from X 2 atoms are missing students. What is the formula is asking. So here X atoms where their students, actually X atoms are present at the corners kada. So present at the corners. So what is the solution students? See here, X atoms are present at the corners. So X atoms, I am taking, this is solution. X atoms present at the corners kada. How many corners will be there? Total 8 corners kada. So I am taking 8 corners. So how many atoms are missing students here? 2 atoms are missing from the corners, correct? So that's why I am taking 8 minus 2 into each corner contribution is how much students? 1 by 8 kada. So then you will get 6 into 1 by 8, correct? 2 4s are 2 3s are. Then answer is 3 by 4. Okay, X value. Now Y value. Now Y value where here not removed kada anything. We didn't remove anything. So only X and Z only remove 2 atoms, correct? Y atoms as it is you have to take, but Y atoms were there at the body center, so that's why 1 atom will be there. Contribution is 1 1. And if I take Z value, so Z atoms were their students at the face centers. Okay, now Z atoms are present at the face centers and removed 2 atoms kada from the face centers. So that's why 2 atoms removed. Face centers, how many face centers students? 6 face centers kada. So 6 minus 2 atoms removed. So that's what is the face center contribution students? 1 by 2. So 6 minus 2 means 4 into 1 by 2. How much students? 2 you will get. So xyz2. Clear this one? xyz2. Now see what is the formula students? How to write? X 3 by 4 y1 z2, correct, but we have to write the simplest form because here fraction is there, we have to write in the simplest form. Then how to write in the denominator what is there, that with all the values we have to multiply with 4. So that's why x 3 by 4 into 4, y 1 into 4, z 2 into 4. Clear this one, 2 into 4. Then what you will get, students? Formula x 3, y 4, z 8. Clear this one? Okay, x3, y4, z8. Clear? So this is the formula of the compound, students. Now see, students, next question. If 25% of x, 50% of z are removed, calculate the formula. We know that already in the given question, x atoms are present at the corners, z atoms are present at the face centers. Correct? X atoms are present at the corners, so z atoms are present at the face centers. Correct, students? That only given the question. Once we will check the question. See, students, here x atoms are present at corners, z atoms are present at the face centers, correct? So by using this question only we are calculating the this question. See, students, if 25% of x, 50% of z are removed, calculate the formula. Now see, students, solution. X atoms kada, x atoms where they are at corners. Corners, how many corners, students? 8 corners. And here how much percentage is removed, students? 25% is removed. So that's why we are taking the 25 by 100. Understanding? 25 by 100 we are taking. Okay na? So 25 by 100 means how much, students? 25 fours are 100. So 4 here how many times? 2 times. So that means two atoms are removed. Are you understanding? 2 atoms are removed. So that means here 2 atoms removed. So that's why we have to calculate total 8 corners kada. How many removed? 2 removed. Each corner contribution is how much? 1 by 8. So then how much you will get? 6 into 1 by 8 you will get. 2 4s are, 2 3s are. So answer is 3 by 4. Now coming to the y. Y atoms where their, students? At the body center kada. So body center here not given in the question about the y. So but not given na. So exactly as it is you have to write about the y. Understanding, students? Now see, students, y atoms where their, students? Y atoms are present at the body center, correct? So that's why body center na. So one body center particle and its contribution is 1 kada. So 1 avutundi. So z is equal to, what is z, students? Here z atoms are present at the face centers. How many face centers? So 6 face centers. So and how much percentage is removed? 50% kada. 50 by 100. So 50 by 100 means 52s are 2. How many times? 3 times. So answer is z. Z is equal to 3. Now what is the formula, students? How to write formula? Formula of the compound x2, y 3 by 4, z 3. Clear this one? But here also fraction is there, so that's why we have to convert into simple ratio, simplest form. So how to write, students? Here in the denominator 4 is there na, so that's why all the values you have to multiply with 4. So that means x 2 into 4, y 3 by 4 into 4, z 3 into 4. Then how much, students? X 8, y 3, now z value 12. So this is about the formula of the compound, students. Clear this question? So like this you have to calculate. Now coming to the fourth question, see, students, if all the atoms present on one face are removed, calculate the formula of the compound. See, students, solution. If all the atoms present on one face, so one face, I am taking one face, students. See here, this is one face. Okay, one face. All the atoms present on one face are removed. On one face, what are the particles are there, students? Here corner particles are there, correct? 4 corners are there. And next edge center particles are there, correct? Edge center particles are there. And next what are there, students? Still face center particle also is there, correct? Face center particle also is there. So but here we give but in the question they given only x atoms or x particles are present at the corners, y particles are present at the body center, and z particles are present at the face centers, correct, students? Here here edge centers also there, so edge center particles also removed, but we no need to think about the edge center. So otherwise you take here one more thing, students. Here you take X, Y, Z already we taken na. So one more I am taking, students. Suppose A atoms I am taking. Suppose A atoms are present at the where I am taking edge centers. Clear this one, edge centers. Okay na. So this also please add this one, then you can easily understand this problem. Okay na. A atoms are present at the edge centers. Okay, is made up of 4 elements you take, students. Then you can easily understand 4 elements X, Y, Z, and another one is A also take. Clear this one, A. Now A atoms where their students, edge centers. Are you following? Edge centers are there, A atoms. Clear this one, edge centers. Now see this one, this problem once observe, students. See, now here what are the particles are there on one face? Total 4 corner particles are there. 1, 2, 3, 4 edge center particles are there. 1 body center particle is there. So these all particles are removed. Then what is the formula is asking. See students, how to remove, how to calculate this one. Suppose here what particles are there? Corners. So X atoms are present at the corners kada. How many corner particles are there? 8 corner particles are there. The total how many removed, students? 1, 2, 3, 4. 8 minus 4. Each corner particle contribution is 1 by 8. Then you will get 4 into 1 by 8, 1 by 2. Okay na? Now Y atoms, see students, Y atoms where they are at the body center. So this is face center kada, body center above. Here there is no body center particles are there, correct? Here body center particle is not removed kada. So as it is you have to take one body center, contribution is 1. And coming to the Z particles, where their students, Z particles at the face centers, correct? Here how many face centers? Only one face center. One face center means here how many faces? Total 6 faces. One face center particle is removed. So 6 minus 1, 5 into each face center contribution is how much, students? Face center contribution is 1 by 2, correct? So answer is 5 by 2. Now coming to the A particle. A particles where there, I told you, I added now here, A particles are present at the edge centers kada. So edge centers, total how many edges, students? Total in cubic unit cell, total 12 edges will be there, correct? A. So 12 edges will be there. How many removed, students? 1, 2, 3, 4 kada removed. That means how much, students? 8. Each edge center contribution is how much, students? 1 by 4 kada edge center contribution. So 2. Answer is 2. Okay now. So this is about the values. Now how to write the formula, students? What is the formula? X 1 by 2, Y 1, Z 5 by 2, A 2, correct? So this is the formula of the compound. But here in the denominator what there 2 is there. So that's why I am multiplying all the values with 2. Simplest form I am taking. So 1 by 2 into 2, Y 1 into 2, Z 5 by 2 into 2, A 2 into 2. Then you will get X 2 to get cancel 1, Y 2, and here 2 to get cancelled, Z 5, A 4. Clear this one? This is the formula of the compound. Understanding? So next question is, students, if all the atoms along one face diagonal are removed, calculate the formula. Face diagonal. So suppose I am taking here, see student, solution. This is one face. This is the face diagonal. Here on the face diagonal, which particles are there, students? 2 corners are there and one face center particle is there, correct? So that means 2. What are the particles, students? Here these 2 are corners, correct? Corner particles are there. This is arrow face center particle, correct? Face center particle. Are you understanding, students? These are all arrow corner particles kada. This one edge center particles, and this one is face center particle, correct? Face center particle, face center, edge center, so, and this is corners. Clear this one? Now coming to here, this question, if all the atoms along and one face diagonal are removed, calculate the formula of the compound asking. So one face diagonal, on one face diagonal what particles are? This one separately I am taking 2 corners. So okay now, one face center is there, correct? 2 corners. So total 2 corners are there and one face center. So these 2 are removed. Okay na, one face center particle is there, these 2 are removed. So see students, corners, total X atoms where the students corners kada, so corners 8 minus 2 corners particles removed, so each corner contribution is 1 by 8. 8 minus 2, 6 into 1 by 8, 2 4s are 2 3s are 3 by 4. And Y atoms where their students, Y atoms are present at the body center, so 1 into 1 as it is 1. And Z atoms where their students, Z atoms where there, so here Z atoms are present at the face centers kada, face centers. So how many face centers are there? Z atoms, so Z atoms, how many face centers are removed? Only one. Total 6 face centers kada, 1 removed into its face center contribution 1 by 2. 5 into 1 by 2, how much students? 5 by 2. So 5 by 2. And here and one more, E also you have to find kada, because A also we are taking na, A also. So A atoms where their edge centers, any edge centers are removed here? No, edge center particles are not removed. So how many edge centers? 12 edge centers. Each edge center contribution 1 by 4, 3. So you will get the 3 answer. Understood, Amma? So this is the 3. Clear this one. So here also you are taking, and what is the formula, students? Here formula is X 3 by 4, Y 5 by 2, Z Y 1, Z 5 by 2, A 3. So then what you will get here, 4 2 is there. LCM is how much, students? 4 2, 2 1s are 2 2s are kada. LCM is 4 out 4 kada. So X 3, here Y 4, Y 4, here 2 4 times 2 times will get cancelled. Z 10, A 3 into 4, 12. This is the formula of the compound, students. And here one more, students, here we are taking one more element kada. A particles are present at the edge centers, I told you na. So that's why here also you take A none. About A also you should write. Okay na. So because of this question, because of this, which question? Fourth question. Because of fourth question, students, fourth question, I am taking A particles also at the edge center. So that's why remaining for this problems also please write about A. So here A value, A particles where their students at edge centers kada, total 12 edge centers kada, and each edge center contribution is how much? 1 by 4. Then you will get 3 kada. So directly you can write A3. So this is the formula. And coming to here, students, what about A students? Here A also you have to write, because here 4 elements I am taking, students. So that's why I am adding A also. So what about A students? X Y Z completed. Okay, now A value. So what is the A value, students? Here A value also add. So here A values where they are at edge centers kada, at edge centers. Okay, here what is the question? 2 atoms are X mixing, only X Z kada. So Z atoms as it is you should write. So A atoms are present where, students? A atoms 8, total 12 edges, so 1 by 4 is the contribution, total 3. So that's why you will get here how much, students? A3 you will get. So if when you multiplied with 4, then you will get the A12. Clear? This is the formula of the compound, A3 by 4. Please add this also, because I am taking one more extra particle, A edge centers. Okay, and next here also calculate the formula. Here also edge centers we didn't remove kada, so that's why as it is I am taking. So edge centers A particles, that is 12 edge centers, contribution is 1 by 4, total value 3. Correct? Then here you will get A3. Here also A3 into 4, then you will get A12. Clear this, students? Please add this A particles also. Okay, now because of this question, fourth question, I am taking A also. Then you will get the clear idea, okay na, about this one. So 4 particles I am taking. Okay, understood this one question? So how to find the formula of the compound in the solid state lesson? Clear this one? How many in the cubic unit cell, what elements are there, what are their contributions, and how to find the formula of the compound in different ways, understanding in different model questions. Adha only corners, X atoms are present at corners, Y atoms are present at the X atoms are present at corners, Y is at the body center, Z is at the face centers. Clear? So these all the problems. Please practice, students, then you can easily then you can easily calculate these problems, you can easily understand. Please watch students. Okay, thank you students. I hope you like this video. Thank you students. Please like, share and comment. Thank you students.